Aviation noise effects on the community and land use and designing mitigation strategies. Following the outline shown, the study explores the sources and impact of aircraft noise from Bahrain International Airport on the different land zones in Muharraq Governorate. It's thought that noise and its adverse effects are underestimated, so our motivation was to better understand how noise particularly affects humans and land use. This understanding could help engineers consider any negative implications to the development and improvement of urban and rural areas alike, bearing in mind the necessary precautions and steps to minimize sources of pollution and disturbance in the environment. Our aim was to study the relationship aviation noise has on community and land use, with the main objective of discussing mitigation strategies that reduce aviation noise effects on people and optimize land use as per engineering standards, all contributing to the Sustainable Development Goals of 2030 Vision Bahrain. Constraints that may affect the results of our study are the COVID-19 pandemic, any errors in the device and information collected from the sample population, there being multiple sources of noise during noise level measurements, and a lack of data availability. The engineering standards used are adopted internationally or in regions like the US or Europe, as well as the standards followed in Bahrain. Aviation noise is the noise that occurs due to the operation of aircraft and is the engine noise or the noise produced as the aircraft travels through the airframe. Increased noise levels produce adverse effects, most notably on the community and land use, both of which go hand in hand.
Our design outline is conducted in 3 stations. First, we will take off with the logistic regression model using the data obtained from the survey in SPSS. Then, the t-test, which will measure the noise levels depending on the number of flights will operate. Finally, we will land with the distance relationship. Our design is based upon noise levels measured at different locations and the survey results. Here are the survey questions, which are mainly will investigate about how people will be affected, considering several aspects of inspection that will be needed during the analysis. The first design methodology we have used is the logistic regression model. This model is used to interpret data and illustrate the relationship between one dependent binary variable and one or more nominal, ordinal, interval, or ratio level independent variables. In the presented case, the target was the type of disease people have, which could be a chronic disease related to high noise exposure. This includes the insomnia, hypertension, heart disease, and other options mentioned by the respondents, while the independent variables include their gender, their age, and this factor was divided into 5 categories in the survey starting from 18 years, since it is the legal adult age in Bahrain, as underage respondents may not be mature enough to understand and respond to the questions accurately, where the last class was 60 years old or above, which corresponds to the retirement age in the country. The third independent variables was the distance from the airport to the locations people exposed to the noise, starting the range with less than 500 meters until 1 kilometer or further distances. The last independent variable covers noise exposure at different zones, varying from residency, school, work, or other locations. Gender and distance parameter will be removed from the model due to a specific reason that will be explained later. And to predict the chance of having a specific disease individually, the Logistic Regression Analysis software SPSS has been used. To use SPSS, coding was applied to the independent variables, and in the regression model, the B coefficient describes the size and direction relationship between a predictor and the response variable. The coding used the value of 0 to be yes and 1 to be no. Therefore, whenever the case is significant, the negative B coefficient values refers to decreasing the likelihood of not having a certain disease due to noise. In other words, when the coefficient is negative, it will increase the possibility of having a certain one, while the positive B coefficient values refers to the opposite case. This is the first trial where gender and distance parameter will be removed from the model because the significant probabilities of having the coefficient 0 was more than 0.05, which is the acceptable limit. So, these two variables will not affect on having any diseases. This table shows the final results after eliminating the variables that has a significant more than 0.05. The result shows that the age does not have a significant effect on heart disease, but it has an effect on hypertension, and since the factor B is positive 0.082, then as the age parameter increases, the possibility of having hypertension will also increase. Age also has an effect on insomnia. With a negative factor of 0.03, then age will decrease the possibility of having this disease. As for the second parameter, which is the residential activities, it will not have a significant effect on heart disease, with a probability of 0.183, as well as hypertension. However, it has an extreme effect on having insomnia. With a negative factor B, it increases the possibility of having insomnia with the values of 1.644. All things considered, the results can show that having residential activities near the airport has more possibility of having insomnia, which proves that residents are the most sensitive groups in terms of disturbance, as they are subjected to noise at their resting zone. In the case of schools, there was no relationship recorded since this group of respondents are mainly the students, which belongs to a young age and represent a smaller portion in the surveyed group, which targets people of age 18 or above. Work activity represents the major group affected by aviation noise in terms of health, of which there is a significant effect on having heart disease with a likelihood of 0.027, or hypertension with a probabilities of 0.023. And having the negative B coefficient indicates a high possibility of having heart disease or hypertension. These high possibilities are directly related to people working in or around the airport, as they are subjected to higher noise levels and for longer durations, escalating the possibilities of building such noise pollution related diseases in comparison to other groups of people. As for insomnia, since these workers may not be resting and living close by the airport, the likelihood of having insomnia was more likely in residential case. For other activities, the possibilities shows that only heart disease has significant effect, and since the B coefficient was positive, the likelihood of having heart disease is low. Since most people are not involved in other activities group as in residential and work, no serious concerns was recorded.
In the survey, respondents were asked to rate how prevalent the noise was prior to and during the COVID-19 pandemic to help understand the effect of number of flights on the noise levels and test the significance. The LAEQ noise levels for 10 flights a day and for 45 flights a day were calculated and plotted to show the variation and were used to calculate the LDEN noise levels and conduct a t-test. The LDEN value for 45 flights a day was 71.7 and for 10 flights a day was 68.9. These values were taken as the X-bar. The standard deviation was also calculated. In the equation shown, N1 and N2 are 24. The t-value was found as 17.75, and when tested at 95% confidence interval in the t-distribution table, indicated a significant difference in the LDEN noise levels.
Hello, I am Fatma Dhahi, and I'll be explaining the distance relationship. In terms of land use, we conducted a distance relationship study. The first chart to the right is an overall judgment about people awareness and sensitivity towards aviation noise at various distances. The second chart to the left features the residential zone as the most disturbed zone even at further distances. This is probably because, unlike at work, people at their resting zone are more sensitive towards noise. And also, since schools were shut down due to the pandemic and the survey was only open to people above the age of 18, educational zone responses were recorded low. Noise levels were measured using the Noise Capture app. The application develops an interactive map which is also available for anyone to access and explore when downloading the application or visiting their website. We did use the earlier feature to compare results obtained from Bahrain International Airport with the results obtained from Hamad International Airport of Qatar, because Qatar is the neighboring country of the kingdom and is also close enough in terms of size. Noise levels recorded in Bahrain were lower than those recorded in Qatar, but not with much difference. Before discussing our own solutions, we opened the session to the respondents from Muharraq Governorate to see their opinions about this topic. Recommendations included suspending flights from 12 to 5 a.m., especially during the winter season, of which the sound is louder. Also, putting dispersing device for sound waves or noise insulators. Other respondents even recommended to transfer the airport to a depopulated area. Increasing vegetation was also recommended, and finding a noise contour map by studying the noise levels effects in the neighboring area by experts. In terms of actual mitigation strategies, transferring the airport is out of discussion due to its high cost, especially after the recent modernization Bahrain International Airport has been through. And anyways, Bahrain is a small country and we are trying to optimize its land use. As for noise cancellation device and increasing vegetation, they are highly recommended in the area. Personal protective equipment is to be studied by the company itself. Further details are available in our report depending on noise levels labors are exposed to. For noise abatement procedures and land use, we will be discussing them in a minute. The first step was comparing measurements in residential areas, work areas, educational areas, and entertainment areas. In all cases, noise levels measured in Bahrain International Airport was always higher than standard noise levels. We then set a comparison between the current land zoning map of Muharraq Governorate prepared by the Ministry of Urban Planning, which is found to the right, and our own suggested map, which is found to the left. The current map features the airport heavily surrounded by residential areas. What we recommend, given the results, is to have the industrial zone at around 800 meters from the runway, the commercial zone at around 900 meters from the runway, the educational zone at around 1.5 kilometers from the runway, and finally, the residential and main hospitals at least 2 kilometers from the runway. In terms of arrivals, we don't have lots of recommendations for the noise abatement technology to be applied here. Noise abatement procedures, given the valid options, can be implemented when departing runway 12L, because departures in 12L affect the new industrial areas, Het and Dilmonia. 30R is already controlled in terms of aviation noise, because the path of the flight will anyway be above the water bodies. Our project addressed 3 out of the 17 SDGs. SDG 3, Good Health and Well-being, SDG 4, Quality Education, SDG 11, to make cities and human settlements inclusive, safe, resilient, and sustainable, to support the 2030 vision of Bahrain. We would like to acknowledge that the research references are available in the report reference paper. All pictures belong to their respective owners. And we would also like to acknowledge the use of Microsoft Excel, Flight Radar 24, the Noise Capture app, SPSS created by IBM, and the discussed standards. Hope you enjoyed your flight with us. Thank you for listening. You may now unfasten your seat belts. The question session is open.